Hello everyone. Today we are going to do some more questions on 1 and on 2, taking examples of simple functions, which you already know. Now I start from the question that is, so that the function f from set of real number to real numbers defined as that is fx is equal to cos x is neither 1 nor on 2. So we start from that is 1 1. It is to check 1 1. It may be so. This is the process of 1 1. If it is 1 1, then we are supposed to prove in general. If not, then we have to raise a contradiction. So for that, just take x means angle. So 0 is equal to cos 0, and the value of cos 0 is 1. Now for contradiction, just think about other angle for which the value of the cosine function remains 1. So this way we get the angle 2 pi. So we get what? Cosine 2 pi and is equal to 1. We write since f of 0 equal to that is 2 pi, but 0 is never equal to 2 pi. Therefore, f is not 1 1. It is actually many 1. Now, for onto, there are three different ways. Either we can find range, and if range equal to codomain of the function, then that is onto, otherwise not. Or we can show any element of its codomain which do not have its pre-image in domain. So simple way is that is codomain of cosine function is equal to what? Set of real numbers. That is what? Minus infinity to plus infinity. But range is equal to that is close interval minus 1 to 1, and simply we write since range is not equal to codomain, therefore f is not onto function, therefore f is neither 1 1 nor onto. This is about this function which is cosine. At the same time, we may use the graph of this function if required. Then we can say it is 1, so 0, this is minus 1. Since for negative real numbers of its codomain, there do not exist its pre-image, that's why the function is not onto. Now just take other function. Another function is that is very simple, that is take absolute value function or modulus function. For modulus function, very same. Starting from 1 1, we write we have f of that is minus 2 is equal to minus 2, and it comes as 2. At the same time, that is it is equal to 2, it is equal to 2, therefore image of minus 2 is equal to image of 2, but minus 2 never be equal to 2, therefore f is not 1 1. So modulus function is minimum function. Now let's check for onto. For onto, again we can use previous method, writing its range and its codomain. So either we write that is codomain of f equal to what? R. Its range equal to non-negative real numbers. So it is 0 to plus infinity. Since range is not equal to codomain, therefore f is not onto. Or we can say, if we use the graph, then the graph of modulus function is y equal to x, y is equal to minus x, and it is 0. Now here we see, since this portion it is negative real numbers, since negative real numbers do not have their pre-images in its codomain, that's why it is also onto. We may write R negative real numbers do not have their pre-images in, that is, domain of the function, therefore f is not onto. So f is neither 1 nor onto function. This is about modulus function. Same way we can explain, that is for greatest integer function. This is for greatest integer function. Again it is neither 1 nor onto. This time when we take this type of element, it means here that is, just take 2.8 and it is equal to 2.8. It means it is real number and its image under greatest integer function will be the integer just less than that real number, and it comes as 2. At the same time, when I write it is 2.1, it is equal to 2.1, it also comes as 2. Therefore image of 2.8 equal to the image of 2.1, but 2.8 is not equal to 2.1. Therefore that is f is not 1. At the same time we may use this method. Codomain is R. Then what's about the range of greatest integer function? As you know from class 11, it is actually set of integers, and here again same case arises, range is not equal to codomain, that's why f is not onto function. Here we may write non, or we write, that is what, if we write graph x, then there is non-integral values of its codomain of R, that is called codomain, do not have their pre-images in domain of the function. Therefore f is not onto. The same case, it is neither 1 nor onto. Next situation is, that is, in case when we take fx as, just take exponential function. So is 1 but into, that is, function. For this we start from, that is 1, use the algorithm, that is fx1 is equal to fx2. It implies e to the power x1, e to the power x2. Since e is the base and it has fixed value, that's why it implies x1 equal to x2. Since from here we get fx1 equal to fx2, that's why it is Therefore, f is 1 1 function. Now, for onto, just use the algorithm. Directly we start, that is fx is equal to 1. This is defined for functions. Now put the value of fx. In this case it is e power x and it is equal to y. Taking log of both the sides, we get x is equal to log of y. Since here by definition of logarithmic function y is always positive, therefore for each y to be the element of R, that is codomain, there do not exist its pre-image in, that is R, that is domain. It means x is not an element of R when y is what? Negative. It is the restriction. So therefore f is not onto, it is into function. Now I am going to start next topic of the same chapter, and that is called composition of functions. How we get composition of two functions? Actually, when we define that is composition of two functions, actually the composition of two functions is a chain process in which output of the first function becomes the input of the second function. So composition of two functions is a chain process in which output of, that is first function, becomes input for second function. Okay, that is chain process. Now just try to define. For definition we require two functions with some restrictions, and due to some restrictions we are required only three sets. So let f is a function from a to b and g is a function from b to c, getting it is output and it is input. B two functions. Then the composition of f and g is a function. What type of function? It is denoted as, that is f and composition g. We read as g circle f. It is a function which takes the domain of this function, that is a, and the codomain of this function, that is called c, and it is defined as, that is f composition g, then x is equal to the value of fx under g for all x to be the. Okay, this is about the definition. Now if we think function as a machine, that is function as a machine, then machine one is for function f and other machine is function g. Then how we combine? If we consider function as a machine and one machine having what? Input as well as output. Then the machine F. Just think about the machine F for function F. It has input as well as it has output. One more machine is there, that is for function G. So just take it. This is another machine, so we may join it. It again has input and output. So this is machine F, then this is machine G. It also have input as well as output. Then the machine, both for F and G, arranged in a cabinet is called, that is what? Composite machine, or it is called, that is F composition G. Then what's about the input and output? If we give here input X, then from here we get, that is output, that is Fx. By the restriction, this is the input for second machine. This is also input for second machine, and from here we get that output. This is about combination of function. It means actually it is a cabinet of two machines. One machine for the function F and other machine for the function G. And when we get total arranged in a cabinet, then we get final output as what? Composite function of F and G. Okay.